Hi, class. Obviously, you have found some headphones or earbuds, but today what I want to talk about is the next two sections in the book, 2.3 and 2.4. And again, please, if you find any reason to be curious about either of these sections, just go to the textbook. But let me just show you in brief what we're going to face today. I just want to get you prepared for the homework that I have for you, the online assignment that I want you to start in class and possibly get close to finishing so that you don't have very much homework over the homecoming weekend. So today, just a quick review of what we've done so far is that we've talked about inequalities, and in this case we have, last night anyway, you had an opportunity to deal with adding and subtracting to both sides of an inequality. And we recognize that if we have something, let's take something obvious like 4 is greater than 3, and we add numbers to both sides of the inequality, plus 5, say, and another plus 5, we find that the inequality still holds, and that in this case 9 is greater than 8. So this is telling us that by adding to both sides of an inequality, we don't change the direction of the inequality. Same thing goes with subtraction. If I have something like 4 is greater than 3 and I subtract 2 from both sides, then again I get a 2 is greater than 1, also a true statement, right? So this told us yesterday that we can add or subtract to both sides of an inequality and nothing's going to happen. One thing that's also true is that if we multiply both sides, so again, this is let me just really quickly put this in. This is adding and subtracting. So the next thing is what happens when we multiply. Now there's two situations that we have. We have multiplication when by numbers that are positive. So multiplying by positive numbers, we get the following. So let's go ahead and start with our 4 is greater than 3. And we'll notice that if I multiply, let's take some random number, it doesn't really matter what it is, but a positive number like 5, if I multiply both sides by 5, I'll find that my inequality still holds true. It's still nothing. Yes, that the inequality is still true. The interesting thing is that when I multiply or divide, by negative, and I should actually put or divide here also, multiply or divide by negative, something strange does happen, and let me show you what that is. So let's take our 4 is greater than 3, and now what I'm going to do is I'm going to multiply by a negative number. Let's just say something easy like -2. So I'll multiply both sides by -2, and I get a -8 here, and I get a -6 here. Now, I'm not sure if you can, if you've done this enough, but you should recognize that -6 is actually larger than -8. So multiplying by a negative or dividing by a negative will result in the inequality being flipped. So this is the rule that's unique only to inequalities. You solve equations, you can multiply, divide, add, or subtract positive and negative numbers without concern, but in terms of the inequalities, you need to remember that multiplying or dividing by a negative will always produce, it will always require you to switch the sign from, in this case, greater than to a less than sign. Let's try one more, just so you can get a sense for, a little bit more of a sense what's going on. We do a division. So let's take something arbitrary. Let me go like a negative 8 is less than 6. So here's another example. And I should just go ahead and put them in. Now, in this case, what I'm going to do is not multiply by negative 2. Let me just divide by negative 2 and see what happens. So negative 8 divided by negative 2, 6 divided by negative 2. Negative over a negative is a positive. I get a 4 here. And on the other side, I end up getting a negative 3. Again, similar to multiplying by a negative, division by a negative also requires us to switch the sign from, in this case, less than to greater than. So I'm hoping that this is the key piece, right? That when we solve inequalities, summary, we solve inequalities exactly the same way that we solve equations, except what? Except when multiplying or dividing by a negative, we must switch the signs. And that's it. What I'd like you to do right now is go ahead and pause this for a moment and take out your student journal. I'd like you to take out your student journal and go to page 40. So do that now, and once you have page 40 in front of you, go ahead and start this back up. Okay, so sign off for now. Okay, so hopefully you've got this page in front of you right now. What I want you to just see is just a review of what we just talked about. If you look over here, it says multiplying or dividing each side of an inequality by the same positive number produces an equivalent inequality. So again, remember, like if in this case they have a negative 6, negative 6 is less than 8. We multiply both sides by 2, and we get negative 12 is less than positive 16, which is a true statement. So what this is telling us, again, is that by multiplying by a positive number, we do not change an inequality. And here it is. The only thing that we need to remember in terms of solving inequalities is that when we multiply, again, we'll start with that same negative 6 is less than 8. When we multiply by the negative 2, we end up getting a 12 and negative 16. And notice that what happens here is that the sign is, I'm sorry, right. Okay, right. The sign had to change from the original less than to greater than. In fact, here, what's interesting, and I think probably makes sense, is that they change the sign as soon as they multiply by the negative 2, and that's to the correct sign. So again, the summary is just that: division or multiplication by negative number is going to switch the sign. Now what I need you to do is to take the handout that you just got from the sub and follow along with me. We're going to finish the handout, and then once you're done with the full handout, your homework is going to be this handout plus you have a small assignment online. So take the handout out. You should have, and if you don't, go ahead and pause this and get it, and go to the next page. And so this is the first page of the handout, and what we're going to be doing is some division. So let's go ahead and this first set is we'll be solving using division or multiplication. So let's look at problem number 1 over here. I would be welcome you to see if you can get ahead of me. So this one we're going to solve for x, and so we divide both sides by a positive 3. When we divide both sides by a positive 3, the sign does not change. We're going to get x is less than or equal to 3. Graphing the solution, what we're just going to look at, we don't have to go crazy, but don't go too not crazy. But anyway, we have let's go with 3. We have 3 and 4 over here and 2 over here. Go ahead and put at least 3 or maybe 5 numbers and then graph it. Less than or equal to means that we're going to have a filled in dot at 3, and we're going to go to the left, less than. Okay, let me do number 5. The rest of them are very similar, and I'm going to ask you to finish these. And so number 5, though, let's go ahead and take a look at it. B over 3 is greater than or equal to -1. In this case, just like I've told you guys before, you need to multiply both sides by the denominator. So the least common denominator, which in this case is just 3. So we have 2 terms. We have a term on the left. We're going to multiply it by 3. Term on the left. On the right, we're going to multiply by 3. Remember that the reason I'm multiplying by the 3 is to get rid of the denominator. So that's gone. The answer is going to be B is greater than or equal to -3. Graphing again, let's go ahead and put -3 in the middle. Put a number to the right and left, just so we get a sense for the number line. And in this case, it's going to be a filled in dot at -3. And it's going to be greater than. We move to the right. There's our graph. The second set of problems are 7 through 12 that you have to do on your own. All right, so now you've got at least a hint on how to start this page. What we're going to do with number 7 is we're going to divide, but recognize, what am I going to divide by? Is the -5. So now the rule comes into play. We have to remember that dividing by -5 means that our sign is going to switch. So let me recopy this down. I'm going to switch the sign by dividing by -5. And that causes the sign to switch. And then I just solve. J now is greater than or equal to -2. Again, get used to graphing. I'm not going to make you draw a whole bunch of points, but -2, it's good to the right is -1, -3, and J is going to be bigger than or equal to -2, which means filled in dot again, arrow to the right. There you go. Let's take a look at, I would like to take a look at number 11 because it's a little different. It's like number 12. So hopefully you'll be able to do it after you see this one. You should be able to be okay for number 12. So we got K over -2. And 2 here. What I'm going to do is because I'm going to multiply both sides by -2, I'm going to switch the sign. And get my -2 here, -2 here. Again, the reason I'm multiplying by -2 is because it's the denominator causing these two to cancel. K, now it's less than -4, graph again. If you want to, you can be less messy than I am here, but not feeling too good today, so you can forgive me. In this case, less than means a hollow dot. Hollow dot means not to include the -4 because it's not equal to. So what I'm going to ask you to do is finish these questions, and once you finish these questions, I will invite you to go to the next. I'd like to pause this, finish these questions. You can work together. You should have there should be some people that you can ask questions of. Try to do as much of it as you can on your own, but then make sure that you use your resources in your friends and colleagues there in the classroom. So pause, finish this, check your answers, and then we'll go to the next page. Okay, welcome to the second page, section 2.4. In section 2.4, we're going to do, what we're going to have is more than one transformation. And instead of just one addition, or one multiplication, or one addition, we're going to have a combination of division and multiplication and subtraction and addition. So let's go ahead and take a look at, this exercises 1 through 3. I'm going to help you match. Number 2. So in this case, it's this problem here. What we have again is an inequality. Remember again, there's only one rule that we need to remember, is that when we multiply or divide by a negative number, we're going to change the sign. In this case, it's not going to happen. But I'm going to solve this just like an equation. I'm going to subtract 5 from both sides first, and now I end up with a 3m is less than or equal to, in this case, 3. Now I divide by positive 3, and division by positive 3 does nothing to the sign. I just get an m is less than or equal to 1. So question is, which graph shows 1 m being less than or equal to 1? It's got to be here, right? This graph here. So 2 matches with A. So what you should do right now is see if you can't do one or two. I'll say let's go ahead and do number 3. I want you to pause for a moment and do number 3, and then when you turn this back on, you will see number 3 completed. So pause now and see if you can do number 3. Okay, I'm sure you're back unless you watched me do that whole thing. But anyway, step 1, just like solving an equation, we subtracted the 3 from both sides. And once we subtracted the 3 from both sides, then we had the negative. Sorry about that. You ended up with -4. X equals 8. Now we need to divide by the -4, and remember, what does that do? It's going to cause us to switch the sign to a greater than sign. And so now we get X is greater than or equal to 8 divided by -4 is -2. So the only graph for that is going to be X is bigger than or equal to -2. That is going to be a hollow dot. Sorry about that. It's going to be a filled-in dot that's going to go to the right from -2. So that's going to be B. 3 is going to be B. All right, get back to my pen. Moving down here, again, we have the same thing going on. So let's go ahead and let me just do a couple of each, and then you guys can finish this sheet on your own. If you've already figured out that you can do all this on your own, hopefully you're done with the sheet. So at any time, if you want to take off, you can just finish it on your own. So number 5, 4t. Okay, we need to subtract 11 first, which is fine, doesn't change the sign. We get 4t greater than or equal to -4. Dividing both sides by a +4 does not change the direction of the sign. T is greater than or equal to -1. And then they want you to quickly graph the solution. Try not to take up too, because I didn't leave much space for you guys, but anyway, let's go. In this case, it's going to be greater than or equal to -1. That means we're going to have a filled in dot going to the right. Sorry about the little mess there. Number 8. We can do this one of two ways. One of the ways that I've been trying to tell you guys is to multiply every term by 3. That's what I'm going to do in this case. It's a +3, so nothing changes. You might want to put your little reminder of the 3 being multiplied by every term here. So the 3's cancel here. It leaves me with k plus 18 less than 21. No sign change because we multiplied by a +3. I subtract 18 from both sides, and I get k is less than 3. Sorry about that. So give me a 3, and I'll go to 4 here, 2 here, and I need a hollow dot and less than from 3, and that's my graph. Sorry, it's such a mess. On the bottom 4, the bottom 6 are going to ask you to, they are a little bit more complicated, and let's go ahead and look at number 11. Number 11 is going to have an interesting situation for us. We're going to watch what happens when we subtract the 5k from both sides. Subtracting 5k from both sides leaves us with -7 is greater than or equal to 8. Well, that's not true. Therefore, no solution. Okay, let's go ahead to number 17. 9p plus 18. Just distributing, guys, right? 9p minus 15. In this case, we get, again, we subtract the 9p from both sides, and we get +18 is less than or equal to -15. This is not true. Again, we get no solution. I think we still need to do, I only have 2 there. All right, 12. The numbers are a little off. So anyway, I want you guys to try numbers 10 and 16 right now. What I'd like you to do is just pause and finish the sheet. And once you're done finishing this sheet, this sheet is going to be, I'm going to ask you to have the sheet with you when you come in on Monday so that I can check this off. This is going to be at least 5 of your 15 points. And then I have an assignment, an online assignment, once you're done, that I'd like you to do that's relatively similar to what you have here. And I will post that assignment. That assignment will be posted and will be on your dashboard on Big Ideas website. All right, so that, once you finish this sheet, go to the homework, do the homework, and you're home free. So take care, all. Have a good weekend, and I'll see you on Monday. Take care now.